Good day, grade 11s. Here's the solutions to exercise 2. So in the first question there, you've been given a point P, 712, 724 in the first quadrant. So that, of course, would mean that the x value, the x distance there, is 7, right? So the x is 7 there, and then that means the y is equal to 24. Alright, so the first thing you would want to do is to work out the length of OP, the radius of that circle that's going around, right? P is a point on the circle. So just to clarify that, so imagine there's this circle, and it's got that certain radius that you're working out now, and P can be any point on that circle, and that's absolute length. Alright, so we're going to use Pythagoras to work out OP. So OP square, the hypotenuse square, is equal to the sum of the two short side squares, so 7 square plus by 24 square. And so therefore OP is equal to 625, therefore OP is going to equal to 25. Right, so we know that the radius there is equal to 25. Then they ask you to find the values of the ratios, right? If they're talking about sine theta, cos theta, tan theta, they're talking about the ratios of those trig functions with a specific angle. So we know that sine theta is opposite of a hypotenuse, right? And in terms of these diagrams, right, triangles in a quadrant, so if that is theta, that is x, that's y, and that is, say for example, that's z, or the radius. So what we can say is, so x there would be the adjacent, right? So that's the adjacent, that's the opposite, that's the hypotenuse. So therefore we can write it in terms of x, y, and r. So that's not too bad. So sine theta is going to equal to y over r. Cos theta is going to equal to x over r. And tan theta is going to equal to y over x, right? The opposite over the adjacent. Okay, so that's just saying, remember that 24 was the y, so that's x, that's y, right? So that's the same as the adjacent is now x, the opposite is now y, and the hypotenuse is the radius. Okay, so what is the ratio of sine theta? Y over r is going to equal to 24 over 25. Cos theta is x over r, so that is 7 over 25. And then tan theta is equal to y over x, so that is 24 over 7. You leave it like that, as simplified fractions. These questions are assessing whether you know the ratios. They don't want you to work out the size of theta, the magnitude of the angle, and then to plug that in your calculator. This is all to do with the ratios of those trig functions, right? Let's look at question 1.2. So again, you've been given point P. P is now in the second quadrant, minus 3, 4. So that would mean that this x value is negative 3, right? Although that distance is 3, x is minus 3 because it's on the negative side, right? So that is negative 3, negative part of the x-axis. Y is positive, so that's 4. And then if you're going to use Pythagoras to find the hypotenuse, you're going to get 5, right? As a 3, 4, 5 triangle. So that's not too bad. So again, sine theta is equal to opposite over hypotenuse, which is equal to 4 over 5. Cos theta is equal to adjacent over hypotenuse, in other words, x over r, which is equal to negative 3 over 5. And tan theta is equal to opposite over adjacent, so that is equal to 4 over negative 3. So it's negative 4/3. Right, and you can see from the ratios, of course, sine's ratio is positive, 4 over 5 in the second quadrant. Remember, sine is positive there. Cos's ratio is negative, and tan's ratio is negative. So that kind of makes sense. So sometimes there's a question about why would we say this is theta here, right? If this whole angle, if they told you that this part is theta. Well, say for example, this angle here was 150 degrees. You would say, well, 150 degrees is equal to 180 minus whatever that acute angle is, right? So in other words, 180 minus 30 is equal to 150 degrees. Okay, in the same sense, so we want our theta to be an acute angle. So don't overcomplicate this. So if theta is in the first quadrant, well, that is just like very basic. That's just how we did question 1.1. Okay, so theta is there. If you're looking at an angle that's in other words, the reflex angle that's going in quadrant 2, you're going to be looking at 180 minus theta, right? Theta is there. So if you're looking at an angle that's all the way there, that is going to be 180 plus theta, right? And then if you're going to look at an angle that went all the way around and in the fourth quadrant there, right, that is going to be 360 minus theta. We're going to look at co-functions, co-angles a bit later and what happens to those ratios, but at this stage we are just sticking to triangles that forms like a bow tie, right? So quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Okay, let's look at 1.3 now. So P is a point in the third quadrant, minus 5, minus 10. So that would mean if we're going to draw the triangle, so that means the x value there is now negative and the y value is negative. Remember which function will have a positive ratio in the third quadrant? Only tan, right? Because tan is y of x, opposite of adjacent, and both are negative, so you'll have a positive ratio. All the others would be negative. I mean cos and tan. Cos and sine, tan will have a positive ratio. So let's look at this quickly. So if we want to find the angle that went over 180 degrees, right? So that is the same as just saying 180 degrees plus this reference angle. Okay, so that's what we're going to do now. So we're talking about sine theta, cos theta, tan theta. It's then 180 degrees plus that reference angle. Okay, so let's go for it. So sine theta is going to equal to opposite of the hypotenuse, so that's y over r, and that is equal to, and first we need to find the hypotenuse. So what is the hypotenuse going to be? You're going to work out the hypotenuse by saying minus 5 square plus pi minus 10 square is equal to the radius square, right? Hypotenuse square. So that is 25 plus 100 is 125. So the ratio is equal to the root of 125. You don't need, we urge you not to use your calculator with these, right? You can simplify this. That's the same as 5 root 5, right? But whether you use root 125 or 5 root 5, it's no big deal. I mean, the one is in third form, but don't give me the decimals. If you know what the root of 125 in your head is equal to 11.180333989, just be humble about it. Just leave it in third form. Okay, so that's all we need. So let's leave it as a root of 125 because I think that's what the majority of you did. 5 root 5 is just a bit more beautiful. So sine theta is equal to y over r. So therefore that is equal to negative 10 over the root of 125. I'm just stressing again the radius, the hypotenuse, and all of these will be a positive. Okay. And then cos theta is equal to x over r, and that is equal to negative 5 over the root of 125. And then tan theta is equal to y over x, so that is equal to y is negative 10, x is negative 5, so tan theta is going to equal to positive 2. So tan's got the only positive ratio there, sine and cos, they're negative. Finally, let's look at a point in the fourth quadrant. So we've got the point here 5 minus 3 for question 1.4. So that means if you draw a right angle triangle in that fourth quadrant, so that is your 90 degree angle, that the x value is 5, the y value is negative 3, and we can find the radius, OP, by using Pythagoras. So that would be 5 square plus pi negative 3 square is equal to OP square. So which is equal to 25 plus by 9 is equal to OP square. So OP is equal to the root of 34. Alright, so therefore we know this is equal to the root of 34. So, and you leave it like that. If you know what the root of 34 is to 8 decimal places, good for you. Get out more, or well, maybe not now, but you know, just that's great, but leave it in insert form. All right, so if we want to find an angle that's all the way in the fourth quadrant, so that is of course the same as 360 degrees minus this reference angle there, right? And so let's go for this. And so what we've got is, if we're going to work out what sine theta then is going to equal to the opposite over the hypotenuse, y over r, and that then is equal to negative 3 over root 34. And we've got cos theta, which is equal to x over r. X is equal to 5, and y is equal, r is equal to the root of 34. Again, that r should be positive, no? And then tan theta is equal to opposite over adjacent, y over x, and then that is equal to negative 3 over 5. Okay, so there's those ratios, and again you can see that sine's negative there, tan is negative, remember cos is the one with a positive ratio in the last quadrant. Let's look at question 2 then, exercise 2. So in each figure, the length of x, y, and the radius, its form is necessary to find, and then write down the 3 trig ratios for each given angle. For example, sine of 600 degrees, that clearly should be 60 degrees. So, and then tan of 135, cos of 210, and sine of 300. Give your answers with rational denominators. Okay, let's go for it. So in the first one, we've got x that is equal to 1. We've got, remember, that's the point P1, so x and y, that is equal to the root of 3. And then we can use Pythagoras to find OP, so that would be 1 square plus root 3 square is equal to OP square. So that is equal to 1 plus by 3 is equal to OP square. So OP is going to equal to 4, and then this is the square root of 4, so which is 2. So you know the radius is equal to 2. So that would mean sine there, sine of 60 degrees is going to equal to root 3 over 2, and that's of course special angles, remember that. Cos of 60 degrees there is going to equal to 1 over 2. Of course, cos of 60 is a half. And then tan of 60 degrees is going to equal to the square root of 3 over 1, y over x. So that's equal to just the square root of 3. In the second question, so we've got an angle there of 135. So that means this little reference angle here is equal to 45 degrees there. Okay, so that's equal to 45 degrees. So we've got an x value there that is negative 2. We've got a y value there that's 2. And then we can use Pythagoras to find OP. So OP is going to equal to the sum of those two short side squares, right? Is equal to the hypotenuse square. So 4 plus by 4 is equal to OP square. So OP square is going to equal to 8. So it's the root of 8. And that is, of course, the same as 2 root 2. That's also, that's just insert form. Did they ask you to give it insert form? Insert form if necessary. So root 8, or okay, so 2 root 2. Let's do 2 root 2. Okay, let's go for it. So sine of 45 degrees is then equal to, so opposite of hypotenuse, y over r, so it's equal to 2 over 2 root 2. They asked you to give your answers with rational denominators, and remember that's why we did exponents and inserts. So that then is the same as saying 1 over root 2. If you divide those 2's, okay, does make sense? You divide it's 1 term, so you divide 2 divided by 2 is 1. And then you're going to rationalize the denominator. Remember the idea is you multiply it by 1. Okay, you can multiply anything by 1 and it still stays the same. And what is 1 equal to? Anything divided by the same thing except for 0. So we're going to multiply this by square root of 2 over square root of 2. So then you just multiply it by the denominator over the denominator if it's one term. So therefore we've got 1 over the root of 2 times by square root of 2 over square root of 2, because that's 1, so that's legal. And what's going to happen then? You're going to get 1 times by root 2 is root 2, and root 2 times by root 2 on the denominator is 2. So what I'm saying is 2 over 2 root 2 is exactly the same as root 2 over 2. So that's just what they mean by write it with rational denominators. Cos 45 will be equal to x over r, so minus 2 over 2 root 2. So that would mean cos 45 is equal to minus 1 over root 2. And if we just rationalize the denominator, it's exactly the same story. Multiply that by root 2 over root 2, and then you're going to get minus root 2 over 2. Okay, so that's not a big deal. And then last part is tan of 45 degrees. Tan of 45 will then be 2 over minus 2, right? Y over x, opposite over adjacent. So 2 over minus 2, which is equal to minus 1. Okay, so 2.3 there. So we've got an angle of 210 degrees. This means this little reference angle there would be, of course, 180 degrees plus 30 degrees. Okay, so that's good. In this case, the hypotenuse, the radius, has been given to you as 2. The y value has been given to you as minus 1. And then you can use Pythagoras to work out the xy, to work out the x value. And that, of course, is minus root 3. Alright, so it's sum of the two short side squares equal to the hypotenuse square, and then so that is minus root 3. Okay, so let's go for it. So therefore, sine of 30 degrees is going to equal to opposite of hypotenuse minus 1 over 2. Cos of 30 degrees is going to equal to minus root 3 over 2, and tan of 30 degrees is going to equal to minus 1 over minus root 3, which is equal to 1 over root 3. Okay, so sine and cos is negative there. Tan 30, we can just write it with a positive denominator. So you multiply this with a root 3 over root 3. So then you get root 3 over 3. All right, so then it's got a positive denominator. So I just want to point out to you then again that sine of 30 is minus a half. That is, of course, then the same as saying sine of 210 degrees. That's exactly the same. Sine of 210, the whole angle is equal to sine of 30 degrees there. Cos of 210 degrees is equal to cos of 30, and then tan of 210 degrees is equal to tan of 30. So those ratios of tan 210, cos 210, sin 210 will be the same as each of those respective sin 30, cos 30, and tan 30 angles. Again, so maybe I didn't say that earlier. Hopefully that makes sense. And then lastly, question 2.4. So what we have there is we've got an angle of 300 degrees. That means this little reference angle there, of course, would be 60 degrees, right? 360 minus 60 is 300 degrees. Okay, so let's go for it. So again, the hypotenuse has been given to you as 2. The y value has been given to you as minus the root of 3. And that would mean the x value is equal to 1. All right, so if you use Pythagoras, right? And just if you're unsure about that, so the x value there, x squared plus minus, root 3 square is equal to 2 square. So x plus by root 3 square, which is equal to 3. So x plus by 3 is equal to 4. So therefore x is equal to x square is equal to 1, x is equal to 1. Plus or minus 1, but in this case it's a positive one, right? But you should know that from your special angles. Okay, so let's go for it. So therefore sine of 60 degrees is going to equal to opposite of hypotenuse minus root 3 over 2. Cos of 60 degrees is going to equal to 1 over 2. And tan of 60 degrees is then going to equal to minus root 3 over 1, right? So that, of course, would be the same ratio as sine of 300. That's the same ratio of cos of 300, and that's the same ratio of tan of 300. All right.